Next one is G01, that is linear interpolation. So here we want the tool to move along a straight line path. So here we will be specifying the end point to which the tool has to move. So suppose we are having certain points P1, P2 and P3. You are having a spindle axis and you are having a workpiece which is held in a chuck. We are having the origin 00 for the coordinate system in which we are doing the programming. Now say the tool is at point P1. So the tool is already present at the point P1. Now if we want to move the tool to any other point, say P2 or P3 along a straight line, then we will use the linear interpolation. So the syntax will be G01, that is a G code for the linear interpolation. Then we have to specify to which point the tool has to move. So X and A, Z and B. Here A represents the X coordinate and B represents the Z coordinate. Then FC, here C represents the feed rate at which the tool has to move. So unlike the rapid motion, in case of the linear interpolation, we have to specify the speed at which the tool has to move towards the end point. So now we'll see the example here. So we are having the tool at P1. We want to move the tool to the point P2. So move the tool from P1 to point P2 whose coordinates are 50, minus 40. Here X is 50, Z is minus 40. By linear motion, that is it has to move along a straight line path at 80 millimeter per minute. So that is the feed rate F, that is 80 millimeter per minute. So we will write it as F80. Then we have to use the syntax here G01, X and A. So A is the X coordinate of the end point. So end point is P2. So A will be X coordinate of the point P2, that is 50. And ZB, B will be the Z coordinate of the end point, that is minus 40. So Z minus 40. And FC, C is the feed rate, that is 80 millimeter per minute. So we will write it as F80. So you can see G01, X50, Z minus 40 and F80. So whenever the controller reads this particular block, it will bring the tool to the point X50 and Z minus 40, that is point P2 at a feed rate of 80 millimeter per minute. So whatever the starting point is there, it will join the end point along a straight line, calculates the intermediate points, and the tool will move through all the intermediate points at a rate of 80 millimeter per minute. So now we will take one more step. We are having two motions. So from P1 it has to move to point P2 which is 50, minus 40, and then it has to move to point P3 which is 80, minus 60 by linear motion at 80 millimeter per minute. So the feed rate is same for both the moments, that is from P1 to P2 and then from P2 to P3. So how to write about it? So first motion is P1 to P2. So you have to move along a straight line. So we will write it as G01, X50, Z minus 40. So 50 and minus 40 are the X and Z coordinates respectively. Then we are writing as F80 because 80 is the feed rate at which the tool has to move, 80 millimeter per minute. So the tool will move from P1 to P2. Then the tool has to move from P2 to P3. So this is a motion that is required. So we will write as G01, X80, Z minus 60 and F80. So here F80 is there in second line because for both the motions the feed rate is 80 millimeter per minute. If it is different, then we can change it to any value that is required. So now we are seeing G01 is repeated, F80 is also repeated in the second line. So whatever the same parameters are there, we can as well eliminate them from the program. It is not required to type it again. You can simply write it as X80 and Z minus 60 as the second line. So when the controller reads this first line, that is G01, X50, Z minus 40, F80. So the tool can be anywhere. It will come to this particular point X50, Z minus 40 at a rate of 80 millimeter along a straight line. Then when it reads X80 and Z minus 60, it will automatically take it as G01 because it is already provided. Then it will take it as F80 because that is the current feed rate. So from P2 to P3 it will move along a straight line and at a rate of 80 millimeter per minute. So in this way, whenever we want the straight line motion, so it may be for taper turning, or it may be for turning operation, or it may be for facing operation, or for any other profile operation where the 2 points are connected by a straight line, we can use G01.